Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss one topic from organic chemistry from the chapter biomolecules. The name of this topic, title for this topic is cyclic structure of glucose. As we know that glucose is a carbohydrate, it is containing the aldehydic functional group in it. It is containing 6 carbon atoms in it. But after studying the open structure of glucose, scientists have concluded that even despite of having so many properties of or so many chemical properties of the aldehydic functional group, glucose exists in the form of cyclic structure as well, right? So today we are going to discuss this cyclic structure for glucose molecule. But before going for the cyclic structure, I am just going to show you the open structure of the glucose molecule, and I am going to tell you few things, that is how to write down the open structure of glucose molecule. So as we know that the glucose molecular formula for glucose is C6H12O6. There are 6 carbon atoms present in it, and aldehyde is the functional group. Therefore this is an aldohexose sugar. Okay, aldo stands for aldehydic functional group, and hexose stands for there are 6 carbon atoms in it, right? Okay, so let us see how to draw this aldohexose. So it's very easy. So what you have to do, you have to draw 6 carbon atoms in a row like this. The first carbon atom is the CHO functional group, that is nothing but aldehydic functional group. Last is the CH2OH, and then you have to draw it in this way. You have to draw OH, then H, then OH and OH. So this sequence you have to remember. So wherever there is OH, left hand side you are going to draw H, and wherever there is H, left hand side you are going to draw OH. So this is how we can draw the open structure of glucose molecule, right? Okay, now if you observe this structure, if you observe this anomeric carbon atom, that is this second last carbon atom, this carbon atom, on this carbon atom the OH group is on the right hand side, right? On this carbon atom the OH group is on the right hand side. When OH group is present on right hand side of this anomeric carbon atom, then this kind of sugar is called as D sugar, right? D, that is capital D. Capital D has nothing to do with small d. These two are completely different things. Small d we are going to discuss later. Capital D is just a nomenclature method, right? When OH group on anomeric carbon atom, this is called as anomeric carbon atom, second last carbon atom. If it is on right hand side D, if it is on left hand side L. As here this is present on right hand side, so this is a D aldohexose, right? This is D aldohexose, right? D, capital D stands for the OH group is on the right hand side, and aldohexose stand for it is the hexose sugar, 6 carbon, and aldehyde is the functional group. Okay, or we can represent it like this also. Instead of drawing all the carbon atoms, you can simply draw the like this. Then OH, H, OH, OH, right? So this is how you can write down the structure of, this is the open structure, okay? This is the open structure of glucose. Open structure of glucose. Now from this open structure only we are going to see how to reach or how to draw the cyclic structure of glucose, okay? You can just take a screenshot of this page first of all. Okay, yes. Now let us see first of all what are the reason for the studying the cyclic structure. Okay, why scientists thought that glucose can exist in form of the cyclic structure. Okay, so let us see those reasons, the facts. Okay, so first fact is that despite of having CHO group, glucose does not give shift test, which is the characteristic test for shift aldehyde functional group, and does not form hydrogen sulfide addition product. Okay, these are the two characteristic tests for the aldehyde functional group. But glucose, in spite of having CHO group, if CHO is there, it should show this reaction, but it's not showing. Okay, this is the first fact. Then let us see the second fact. The pentaacetate of glucose, does not react with hydroxylamine. Okay, this reaction is also the characteristic reaction of aldehydes. These reactions, these are included in the aldehyde ketones and carboxylic acid, the chapter which we have already discussed, right? So these two reactions, that is, first is the shift test, then hydrogen sulfate addition reaction, and then hydroxylamine reaction. These reactions are not shown by glucose in spite of having the CHO group. That means CHO group is present, but that is not free, right? That CHO group is not free for long time. It is immediately undergoing the cyclization, right? It is immediately undergoing the cyclization. Let us see how the cyclization takes place. Okay, so I will draw. So this is aldehyde functional group, glucose first functional group, and this is the first OH, then this is H, then again OH, then again OH. So this particular OH I will draw like this, and then CH2OH. Okay, and then again here it is H, then here is OH, H and H, right? So this is nothing but your D glucose, right? This is nothing but your D glucose. Okay, glucose stands for, it is open chain, right? Okay, now here here in the same structure, within the same structure, you can see there is aldehydic function. In the same structure you can see there is aldehydic functional group as well as OH group, right? These OH groups are also there, but these OH groups are not taking part in the reaction. This second last, which is anomeric carbon atom, this OH group is taking part in the reaction. What type of reaction? Let us see. First of all, aldehydes have a tendency to react with the alcohol to form the hemiacetal. Okay, that reaction also we have discussed in the aldehyde ketone carboxylic acid chapter. What is that reaction? See, this is like, so RCHO, if it is treated with the alcohol, okay, alcohols are nothing but the ROH, right? Alcohols are nothing but the ROH. So what happens when alcohols are reacting with the aldehydes are reacting with the alcohol? We are getting the hemiacetal formation, right? What is the hemiacetal formation? What happens? It gets shifted on this, and this oxygen attacks on this, right? So what will be the product? We will get RCH, then this is OR, and this H will be attached on this O. As these reactions we have already discussed, I am just writing it fast. So we will get this kind of product, which is called as hemiacetal, right? Hemiacetal, okay, or acetal you can say. Now what happens here, also the same kind of reaction takes place, but as here in this case both aldehyde and alcohol, they are present in the same compound, right? They are present in the same compound, so we will get the cyclic product, right? Because both the groups are in the same compound, so cyclic product we will get, right? Okay, so what type of reaction it is going to take place, let me just show it to you. So as I have told you, this will be shifted on oxygen, and this anomeric carbon's OH group, this oxygen is going to attack on this carbonyl carbon, right? Okay, it is going to attack on this like this, okay, and we will get the product formation. Okay, now here we are getting two product formation. What type of two products are obtained, let us see. The products they are different from each other on the basis of the position of OH group, that's it. There is no any other difference in it. Let us see how to draw it. Okay, first of all draw all the carbon atoms, right? All the 6 carbon atoms like this, like this, like this. Last carbon atom is as it is, CH2OH. It will not change, right? Then as I have told you here, the reaction between this and this takes place. Means what? This carbon, aldehydic carbon, and this OH oxygen, they are going to connect to each other. So this OH wala oxygen I am just going to draw in the middle, right? Because I cannot show the linking in this way. Okay, yes. Then what happens here? So there is a bond formation in between this carbon and this middle oxygen. This is the oxygen from this anomeric carbon atom. Okay, just for simplicity purpose I am showing it like this. Okay, now here one more thing, like here I am going to show it like this. There is also reason for that part. Okay, so this is the OH oxygen and this is this. Now this hydrogen of aldehyde is on the right hand side, and then oxygen will go on the left hand side. Okay, then other things remains as it is. So this is your OH, H and OH. Other things are not going to change. Okay, yes, so other OH and H are not going to change. So this is the first thing. I'll just number all the carbon atoms so that you will understand. Numbering will start from aldehydic carbon. 1, 2, 3, 4, 5 and 6, right? Here also this is carbon number 1, 2, 3, 4, 5 and this is 6 carbon. Okay, yes. So this is the one form in which this OH is on the left hand side, right? This is the one form in which this OH is on the left hand side. Let us draw one more form. Okay, yes. So another structure also I will draw. Okay, again all the other things are as it is. Draw all the carbon atoms in a row like this. 1, 2, 3, 4, 5 and 6. Last will be as it is, CH2OH. Okay, then here also again there will be bond formation between this anomeric carbon atom and this oxygen OH I am writing here. Then here, just here OH is on the right hand side. Okay, OH is on the right hand side, H is on the left hand side. That is the only difference in between these two structures. Can you see? Other things are as it is. All other things are as it is. Just the position of OH group is different, right? Yes, here also I can number it. So this is carbon number 1, this is carbon 2, 3, 4, 5 and this is carbon number 6, right? So here we are getting these two different types of the structure. Okay, now if you observe, these two structures are same, just there is only one difference at the carbon number 1 OH group. In case of blue colored structure, the carbon is on the OH group of the carbon is on the left hand side. In case of the orange colored structure, the OH group on the carbon number 1 is on the right hand side, right? So therefore there are two different names to them. So when OH group is on the right hand side, okay, of carbon 1, C1, when OH of C1 on right hand side, I will write down. Okay, so this is called as alpha glucose. Okay, so this is alpha D glucose. Whenever I write down alpha, alpha stands for it is cyclic. Okay, whenever alpha word comes there, alpha stands for cyclic. Here no alpha beta is there, that means it is open. Okay, now what does the alpha stand for? The OH of carbon number 1 C1 is on right hand side, right? OH of the carbon number is on right hand side, and in case of blue structure, this is on the left hand side. It is called as beta form, beta D glucose. Okay, beta, whenever beta word is there, it is cyclic, remember. Okay, this is why this is beta. OH of C1 is on left hand side. Okay, it is on left hand side, right? So these are the two cyclic structures we can have, right? Now these two cyclic structure, okay, alpha and beta forms are called as okay, these two cyclic structures, okay, alpha and beta form of this glucose are called as hemiacetal structures. These are called as hemiacetal structure, right? I have told you why hemiacetal, because they are formed by the reaction between aldehyde and the alcohol group, right? Okay, and then these two form are also called as, okay, one more line I will see, alpha and beta forms are epimers of each other. This is also one type of the isomerism. Okay, epimers of each other. What is the meaning of epimer? That is the difference in OH position. One, in case of one, it is on the left hand side, in case of another, it is on the right hand side. These are called as epimers of each other. Okay, now you can do one thing, you can just take a screenshot of this structure first of all, and then we will start the one more concept related to this. Just take a screenshot. These words are very important, okay? Epimers, then hemiacetal structures. You can see question based on these words in the competitive exams, right? You should know the meanings of these words. Okay, now one more thing I am going to ask you to observe here. Now here you can see this is the carbon number 1 and this was the carbon number 5. Okay, so here when the cyclization takes place in between these two, oxygen will come in between, right? And finally we are getting a 6-membered cycle. Can you see the number of carbon atoms in the cycle? Okay, let me just highlight those carbon atoms, carbon as well as oxygen. 1, 2, 3, 4, 5 and 6. This is a cycle, right? Similar for the left hand side circle structure also. That means after the reaction we are getting a 6-membered product, okay, hexacyclic product including oxygen. Always remember here there was another possibilities also, that is CHO can combine with this oxygen, can combine with this and combine with this also. These other 3 OH groups also were present, but why the reaction was not taking place? Because 6-membered ring is the stable structure. Okay, in whenever there is a 6-membered structure, that is a stable structure. Therefore you can see in nature also so many compounds have 6-membered ring in them. Okay, yes. Now this 6-membered ring containing oxygen, okay, 6-membered ring containing oxygen, there is a name to that ring. Okay, let me just show you that. So whenever the 6-membered ring is present containing oxygen, containing oxygen means what? One will be oxygen, other 5 will be carbon. Okay, so this is a 6-membered ring containing oxygen. Name of this compound is pyran. Okay, name of this compound is pyran. As the name of this compound is pyran, therefore alpha and beta, these structures as they are cycles, are also called as, are also known as Pyranose structures are also known as what? Pyranose. Pyranose means what? Pyran like structure, just like pyran. Okay, 5 carbon atom, 1 oxygen atom, pyranose structure, right? Okay, do you understand that? Alpha and beta form of glucose, as they contain 5 carbon, 1 oxygen atom, total 6 membered ring is there. It is also called as pyranose structure. Remember, pyranose, that is like pyranose. Okay, similar to pyran. Okay, yes. Now we can draw one more structure to them. That is now I am going to tell you how to draw the Haworth structure for this cyclic form. Okay, Haworth is the name of the scientist who has developed this technique to draw the structure of cyclic compound. Okay, Haworth structures for this glucose cyclic structures, right? Okay, now Haworth structure is just like this one. So first of all, I will draw for one form. Okay, use the same color. So first of all, left hand side wala orange color I will draw. So this is very easy to draw. First of all, you have to draw this 6 membered structure or skeleton like this. Okay, yes, so this is the 6 membered skeleton. Okay, then you are going to draw the bonds like this: one up, one down, one up, one down, one up, one down, up and down, like this. Okay, now from oxygen, if you observe, okay, so I'll just minimize this structure. So this is your oxygen. From oxygen, from carbon number 1 to 5 I will draw. Okay, so I will start from carbon number 1. So just before the oxygen, there is carbon number 1. Okay, so there is one very simple trick to draw. If OH group is on the right hand side, draw it below. Okay, yes, just observe the structures. Okay, now here if you observe, carbon number 1 I am going to draw. OH group is on the right hand side, right? When it is on the right hand side, you draw it below. Okay, yes, so this is carbon number 1, carbon just a minute. Then this is carbon number 2, carbon number 3, carbon number 4, carbon number 5. Okay, so OH is below, that OH is on the right hand side, that means you should draw it below like this, then H up. Okay, for carbon number 2, can you see, this is your carbon number 2, OH is again on the right hand side. So right hand side means you are going to draw it below, right? For the carbon number 2 also, and hydrogen up. Carbon number 3, observe the carbon number 3, OH is on the left hand side, so left hand side means it should be up, right? So for carbon number 3, OH will go up, hydrogen will be down, right? Then for carbon number 4, observe OH is again on the right hand side, right? OH is again on the right hand side means what? Down. So like this. Then on the carbon number 5, let us see what is attached on carbon number, this is carbon number 5, right? On carbon number 5, one is hydrogen, another is CH2OH, right? One is hydrogen, another is CH2OH. Always remember, CH2OH you are going to draw always up, right? Because it is a bulky group, you cannot draw it down, and then hydrogen down, right? Do you understand this trick to write down Haworth structure? Just observe this structure. OH is right, down. OH is left, up. Very simple trick. Okay? Yes, by using this trick, we have drawn this Haworth structure for the orange structure. Orange structure is nothing but the alpha D glucose, right? Alpha D glucose means what? OH of C1 is on the right hand side, right? Right hand side means what? It is below. OH of C1 is below. So always remember, whenever you find OH of C1 at this position below, that means this is the alpha anomer. Okay, this is the alpha structure. Do you understand that? Now similarly we are going to draw it for the blue colored cyclic structure. Again similar to orange, I will draw the cyclic structure. 6 membered cyclic ring I am going to draw. 6 membered structures are stable, therefore the compound, whenever the cyclization takes place, cyclization means cycle formation takes place, compound prefer to form the 6-membered ring because it is stable. Okay, then I will number. This is carbon number 1, this is carbon number 2, carbon number 3, carbon number 4, carbon number 5, right? Yes, what I have told you here, in case of beta form, this is the beta form. Observe the positions. OH of carbon number 1, left hand side. Left hand side means what? Up, right? OH up. OH up means hydrogen down. Okay, then carbon number 2, OH is on the right hand, hydrogen left. OH right means OH below. Okay, whenever it is right, below, left, up. Carbon number 3, OH is on the left hand side. Left hand side means up. Carbon number 3, OH up, hydrogen down. Carbon number 4, OH right. Right means below. For carbon number 4, OH is on the right, hydrogen up. Then carbon number 5 is attached to, yes, carbon number 5 is attached to hydrogen and CH2OH. Always remember CH2OH we are going to draw up, right? CH2OH and then hydrogen will be down, right? Then CH2OH is nothing but your 6th carbon, right? So this is how we could draw the Haworth structures. This type of structures are called as Haworth structures for alpha and beta forms, that is pyrano structures, that is hemiacetal structures or epimers of glucose, right? These are the cyclic structure. So cyclic structure can be shown by 2 ways. Can you see? This is the first way. Simply we can show it like this. This is the first way, right? And but more preferably we are going to show it by the Haworth structure like this. In Haworth structure, always remember, if OH is on the downside, OH is below, that is the alpha anomer. Okay, why alpha? Because in alpha OH is on the right. For C1, carbon number 1, OH is on the right hand side. Do you understand that? Whereas in case of beta, OH is on the left hand side. For C1, OH is on the left hand side. Left hand side means it is up. So always remember, when OH is up on the C1, that is the beta anomer, right? Now finally, after drawing the Haworth structure, I am going to show you how to write down the names of these two compounds, right? Okay, let me first of all write down for this one, the alpha structure, right? So first of all, it should always start with alpha. Okay, then a small hyphen, then write down capital D. Capital D stands for this carbon number 4. Okay, capital D stands for carbon number 4. OH group is down, that is right hand side. I have explained this already. Carbon number 4 is the anomeric carbon atom. OH group right hand side, that means D. If it was left hand side, capital L. But in case of glucose, it's not on the left hand, it is on the right hand side only. Okay, then after that again one small dash, then inside the bracket I will write down plus. Okay, this plus, what is the meaning of this plus I will explain. Let me first of all complete the structure name, then again a hyphen, then write down gluco. Why gluco? Because it belongs to glucose. Okay, then write down pyranose. Why pyranose? Because the cyclic structure resembles pyran. Pyran structure I have given to you already. So this is the structure, or this is the actual or proper name for alpha anomer. Okay, then I will draw the name of, or I will write down the name of this beta form as well. Simply we have to change alpha to beta, that's it. Nothing is going to change. Just instead of alpha, we are going to draw beta. So it will be beta, then capital D, then plus, then gluco pyranose. Okay, pyranose. Alpha and beta stands for, or they are related to carbon number 1. Okay, position of OH group, either down or up. Down alpha, up beta. Okay, whereas capital D is related to carbon number 4, anomeric carbon. OH is on the right hand side, that is down, therefore it is capital D. Now what is this plus sign? This plus sign stands for, this is a dextrorotatory isomer. Okay, this plus sign stands for Okay, plus sign stands for, it is related to the optical activity. In the haloalkanes and haloarenes chapter, we have already learnt about the optical activity or optical isomerism, that is stereoisomerism. So I hope you remember that. So plus sign stands for, it is dextrorotatory. Okay, dextrorotatory means what? It will rotate the plane polarized light to the right hand side. Okay, it will rotate it to the right hand side, RHS. And if it is a minus sign, it is also minus sign means again it is related to optical activity only, optical isomerism. It is minus sign means it is levorotatory. Levorotatory stands for left hand side rotation or anti-clockwise rotation, right? Alpha and beta we have learned in today's class. The plus, minus, dextro, levo we had already learned in the haloalkanes and haloarene chapter, so I have not discussed it again here. Okay, so this is very important, guys, to draw, how to draw the Haber structure, and about the positions of these OH groups on anomeric as well as on the carbon number 1. Okay, it decides the name of that particular pyran also. Okay, take a screenshot of this page finally. If you have any doubts, you can just post it here. I'm just sending a message in the chat box. If you have any doubt, please let me know in the chat box. Okay, so I hope it is clear. So if you understand how to convert the given structure into Haber structure, then you will be able to draw the Haber structure. They ask the question based on drawing the Haber structure, like they will give some options, 4 options, and they will ask you which one is the correct Haber structure for alpha form, which one is the correct for beta form. So you should know each and everything, each and every concept which I have discussed with you regarding glucose today was really very important as far as JEE Advance is concerned. Okay, yes, and as well as it's important for mains and NEET exams. Okay, I hope it is clear to you. So today we are going to end the session here. In tomorrow's session we'll discuss the next concept from the next topic. Okay, before ending the class, let me just tell you about daily practice problems. So this is DPP, that is daily practice problem. This is a teacher's portal actually. Similar will be students portal. You can go to resources and then to writing material. In writing material you can see DPP, that is daily practice problems. You can see the questions over here for that particular topic of that particular date session. We are going to download it here. We are going to write down the solutions and answers of these questions on notebook or any paper. Take a picture of it and then you are going to just simply upload it on the portal, your portal, just like you upload it any image on social media. Nowadays students are much more techno savvy than teachers, so you know everything, so how to upload the images and all. And then after that teacher will receive it, teacher will evaluate and let you know the suggestions and corrections wherever required. Okay, I hope it is clear to you. Thank you so much for your precious time, students, and all the best to you. Take care.